Good morning, everybody. Welcome to week 5 of At Home Precalc. We are going to be talking this week about section 8.4, which is matrix inverses and some matrix equations. You want to make sure you have your graphing calculator nearby because that's going to be very helpful in this section. Still working on trying to figure out a way, those of you that don't have access to a graphing calculator, how to get it done. But once again, there is a way to download it on your computer, so let me know if you would like that. Okay, so here we go. We're going to first of all talk about what a multiplicative identity is. As you can see, remember, whenever you multiply a number by 1, it stays the same, so that is known as its multiplicative identity. When we talk about matrices, they show up like this. As you can see, there's ones that go all the way across diagonally from the top left down, and then everything else is zeros. Okay, so that's going to be an important thing to remember as we go through here. Now, when we talk about an inverse, when you multiply something by its reciprocal, that's the inverse. That's the multiplicative inverse, and it ends up making 1. Okay, so when we talk about matrices, let me go back. If you're talking about 2, its inverse would be 1/2, because when you multiply by its reciprocal, we always say it cancels it out. Well, it really makes it into a 1, so that's why it's called that. So what's going to happen here is we're talking about matrices. If you multiply a matrix by its inverse, you will get the identity. Okay, and you'll end up with those ones and zeros. Now, a couple of different things. Okay, if a matrix is not a square matrix, like it's a 2 by 3 or a 1 by 4 or whatever, the numbers are not the same, it doesn't have an inverse, straight up. Okay, if a matrix does have an inverse, then it's considered invertible or non-singular, and a square matrix that has no inverse is called a singular matrix. So if you have a graphing calculator, you might come across that where it's like you try to do an inverse and it says, nope, singular matrix. That means there is no inverse. Okay. So let's talk about what you would do to figure out if B is the multiplicative inverse of A. Well, if this is going to be the multiplicative inverse, then that means that matrix A times matrix B, I'm writing this with my finger, so this might come out nasty, should come out to the identity, and the other way around, matrix B times matrix A should also come out to the identity. Okay, so what you could do, and we talked about multiplying matrices in our graphing calculators last week. If you just make matrix A into a 2 by 2 matrix on your calculator, matrix B a 2 by 2, add these numbers in, multiply them together each way. It does matter. Okay, multiply each way. If you get the identity both times, then it's a yes. Okay, so if you do, let me just do one example here. Second matrix. Oh, wrong button. Second. There we go. All right, so edit matrix A. What is fat fingers here? Okay, so matrix A. There we go. And it's a 2 by 2 matrix. And what were the numbers here? -1, 3, 2, -5. -1, 3, 2, -5. Okay, so that's how we get the matrix A. And then once again, do a second, and then the matrix, edit, go to edit over here, go to matrix B, hit enter. It's another 2 by 2. I totally forgot what the numbers are. Should have written this down. 5, 3, 2, 1. And there's all of our, sounds like a really weird countdown. So get out of this home screen, go back to the home screen, clear everything out, and then second matrix. All right, don't edit now, just hit names. Matrix A times second matrix, go down. Oh, my God. Go down to B, enter. When we multiply them, you see we get the ones down the diagonal, from the top left. Everything else is zeros. That works out perfectly. Okay, and might as well, while we're here, second matrix, let's do it the other way. Matrix B times second matrix A, enter. And there we go. It worked out both times. So therefore, when we go back to this, show that they are inverses, we just did, okay? We did it on the calculator. We got 1, 0, 0, 1 both times. So we know that it is a inverse, okay? Let's move along to, I'm going to skip example 2 just because, I mean, if we were in school, we'd totally do it. Right now, it's a little bit more difficult to do this way. So we're going to talk about what you have to do. What's up, Steve Harvey? We're going to have to talk about what do you do when you have a 2x2 matrix and you want to find its inverse. Now, could you use your calculator? Yes. But there are going to be times where in the future you're going to want to know how to do it this way as well. So I'm going to show you. Okay, but there's a little formula that they give us here if we're talking about a 2x2 matrix that we can find its inverse. Okay, so let's go through on the next page. It goes 1 over AD minus BC times D and A here, negative B, negative C. Sorry about the sloppy handwriting. Trying to write on my finger here on a touch screen. It's a little tricky. Okay, so let's do the inverse, okay? A inverse equals 1 over. So now, A and D, that's these two numbers. All right, so negative 1 times 4 minus B times C, which is negative 2 times 3. And that's going to get multiplied by, notice how if you look, the A and the B, when you go back to the formula, A and D, they switch places. And the B and C numbers in the matrix, they switch signs. So that's what's going to happen here. We have 4 and negative 1, they switch. And then these two numbers, those two numbers switch signs. So it's going to be a positive 2 and a negative 3. All right, so on the bottom we have 1 over 1 times negative 4. I'm sorry, negative 1 times 4 is negative 4 minus negative 2 times 3 is a negative 6, which comes out to equal a 1. After you add, comes out to a 1 over 2 times the matrix that we just wrote down, 4, 2, negative 3, negative 1. Okay, so then move this all down to give us room. You guys will do the checkpoint, right? All right, so multiply each one by 1/2. So it gives us a 2 here, 1, a negative 3 over 2, and a negative 1 over 2 as our inverse. Okay, so the number on the outside, doing that 1 over AD minus BC, that gets us a number that we're going to multiply everything inside the matrix by. Okay, and then you follow the formula to figure out how the numbers on the inside kind of get all jumbled around. Okay, so that is how to do a 2x2 by hand. When we get up to bigger than 2x2 matrices, like a 3x3, there's a way to do it by hand, but my goodness, you do not want to really do all that stuff. So we're going to talk about how to do it in your graphing calculator. So get that bad boy back out. Let's go back here, clear everything out. Let's go to second matrix again. Let's go to edit matrix A. Now it's a 3x3 matrix. Okay, so 1, negative 1, and 1. 1, boom, negative 1, boom, 1, got it. Next, 0, negative 2, and 1. 0, negative 2, 1. Amen. And then lastly, negative 2, boom, negative 3, boom, and a 0, I think. Is that what it was? Some people are over there at home like, yes, dude, just go. All right, so there's our matrix A, okay? It's got 3x3, 3 rows, 3 columns. We put all the numbers in. Once we've done that, let's get out, go back to our home. Oh, my goodness. Second, quit. Okay, get back to our home screen. Now to get our inverse, second matrix. There's matrix A. We put a 3x3. Hit enter, and then the button that we've been hitting to get the matrix that got that little negative 1, hit that button. Okay, A, -1. There's our inverse. Okay, we just found our inverse on our graphing calculator. Can we do this in a 2x2? Yes, if it's all numbers, yes, you could totally do that. Okay, but like I said, sometimes there are purposes. If you see matrices in a class later on in life that you actually have like variables and stuff in there, that's when it actually is useful to do this. Okay, but for the time being, right now, since this is a very abnormal situation, you could just use your calculator to do it. Okay, so good stuff here. So what we got? Let's write it in. Who's got sloppy handwriting? Me. 3, -3 and 1, 3, and -3 and 1, -2, 2, and -1? Yeah. -4, 5, and -2, -4, 5, -2. All right. So we did that in our calculator. Once again, that is available to you. Just wanted to show you how to do it. All right, moving along. Now we are going to do a little bit of solving equations with them, okay? Now, if you have something like this where notice all capital letters are matrices. So matrix A times matrix X equals B. If you want to solve for matrix X, there's no such thing as dividing by matrix A. You can't do AX equals B. So, okay, divide by A. No, okay, that doesn't work. What you have to do is you have to multiply by its inverse. Now notice, if we put an A inverse on the left side of matrix A, then A inverse needs to go on the left side of matrix B over here. Okay? So if we like squeeze the matrix inverse in the middle between A and X, then it would go on the right side of B as well. All right, but that never really happens. So we don't have room that way. So A inverse goes on the left of both of them. So that is how we would find matrix X. So here's how this is going to go. We're going to solve a system by using matrices. We're going to solve a system by using matrices. So first, what we're going to have to do is make them into a matrix. Okay. So the way that this is going to go, if we have a system of equations, all right, X, Y, and Z, that's going to go in this column. All right. Make sure you pay attention to this. All right. They go a little bit more in depth in the book just because, you know, they can write it all out. I have a time limit here. But X, Y, and Z, those variables go down here. Oops. Yeah, I'm just going to write capital X. All right, that's the variable matrix, goes down here. Here's going to be our matrix B. There's going to be our matrix A. So all the coefficients go on this first one. So that first equation is a 1x minus 1y, so -1, plus 1z. There's a 1 there. Second equation, there's no x, so there's a 0 here. And then a -2, and then 1 again, and then -2, -3, 0. And then our matrix B is all of our answers, 2, 2, and a 1/2. So once again, the way that we will find what X equals, our matrix X, our variable matrix, is to do A inverse. Come on. A inverse, let's do it like this, times matrix B. So we're going to have to find what A inverse is. So calculator, second matrix, go edit matrix A. It's already in as a 3x3. So let's see. Let's put in the numbers we just did. 1, -1, and 1. Oh, that's funny. I didn't even notice that they did that. All right, so it's the same numbers that we just did in last example. Okay, so that's actually kind of nice. So we need to also have a matrix B. So second matrix, let's go to edit matrix B. Now matrix B, if you look at it, it is one column. There is 3 rows and 1 column. So it's a 3x1 matrix. And it was 2, 2, and a 1/2. So matrix will change it to a 0.5, but that's what we have. Okay. So now that we have matrix A loaded up and we have matrix B loaded up, to figure out what our answer is going to be, we get out of here, close it. Second, let's go matrix A, hit the inverse, times matrix B. Okay, you guys see that? Matrix A times matrix B. Hit enter. So we end up with a 1/2, a -1/2, and a 1. And guess what that means? That means that's what our, come on, that's what our answer is going to be. That's our ordered triple. 1/2, -1/2, and 1. That's our X, Y, and Z. Okay. So that is essentially what our lesson is this week and on your math lab. A lot of them, there's going to be a few very short questions that are just going to say, all right, plug this in, plug that in, not a big deal. But then there will be a couple like this. So you want to make sure you know how to plug them into your calculator. And if you need to get like a software for your computer or something of that sort, let me know. I can send you a link. And that should do it for this week's lesson. Okay, if you have any other difficulties, please let me know. All right, we're almost there. We're almost done. We only got 1 week left, so we can definitely get this done. Okay, I know it's been a rough stretch, but we're getting through this, and we can finish strong. Okay, have a great week, and I'll talk to you next week.